Electron configuration is the idea of listing out the atomic orbitals of an atom. An atomic orbital is essentially anywhere where an electron may be. We can see that there is a probability area of where the electron might be. An electron configuration allows us to list those atomic orbitals. Let's go to an atom like carbon. It's at group 14, period 2. So the carbon atom is somewhere on like the top right of the periodic table. So it goes through 1s2. It has to go through hydrogen, then to helium. Next, it goes to 2s2. We have to go through lithium, then beryllium. The P block is made up from everything from group 13 all the way to group 18. We only have 2 electrons in the P subshell. Now, why is that? Well, we gotta look at where carbon is. Boron is where the P block initially starts, and the P block has 6 electrons within. We go from boron, then to carbon, and that is why it has a 2p2 subshell. How do we express this in terms of electrons? We can look at the 1s, the 2s, and the 2p subshells individually. Then we use the Pauli exclusion principle. The Pauli exclusion principle essentially states for every atomic orbital, there's only going to be 2 pairs of electrons. They have to have equal and opposite spins. For 1s, start with the upward spin, then downward spin. The reason why we start with the 1s1 subshell is because of Aufbau's principle, which states the lower electron energy levels get filled first, and then the greater ones get filled next. So now, in the 2s subshell, we now start up, and then we go down. Now, the reason why we always start going up is because of Hund's rule, which basically states that we start with the upward spin first for every single one, and then we use the downward spin. Hund's rule is going to be the biggest factor in what makes 2p2 this. We start off with the up, then we go up again, and that's it, because we only have 2 electrons in the 2p subshell. And that is the electron configuration for carbon. 1s2, 2s2, 2p2.